So if you are supposed to determine whether a data set is roughly quadratic or not, one thing you can always do is make a quick sketch of the data. You could put this in Microsoft Excel, or you could put it in an online graphing program to do it really quickly, but it's good to know what the program's doing and do it by hand. So there's two variables, miles per hour, and there's length of skid. We will put miles per hour on the x-axis because the convention, which means like, the pattern we've all decided to adopt, is that the independent variable goes on the x-axis. So the variable causing the effect goes on the x-axis. So miles per hour, it's on the x-axis. And look, the data set set up nicely, so I just go by tens, 10, 20, 30, 40, 50, 60. I'll just label a few of them, so you don't have to watch me painfully write all this. Going by tens. And then length of the skid, this one's a little harder to plot. I see that it starts at $6 and it goes all the way up to $200. So I want to choose a consistent interval so that I can still reach all these numbers. So 1, 2, 3, 4, 5, 6. I guess maybe we could go by 50s. I guess that's a guess. You could always go back and try it again. So we'll put 50 here, 100 here. It has to be consistent. You can't go 50, then 60, then 70, then 200. It's got to be the same amount every interval. Okay, and here's how you plot this first dot. You go to 10 on the x-axis and 6 on the y-axis. And it's a sketch, so you're just making a guess. 6 is really low, right? This is 50, so 6 is probably right down here. So here's 20 on the x-axis, 22 on the y-axis. We're rated a little bit below halfway there. 30 on the x-axis, 50 on the y-axis, that's right here. 40 on the x-axis, a little bit under 100, so that's right here. 50 on the x-axis, 140 on the y-axis, and 60 on the x-axis, 200 on the y-axis. Okay, so is it quadratic? It looks like it might be roughly quadratic because it's making this U shape, right? But we don't have the other side of the U going on here. Okay, so just like in real world math situations, there's no one clear answer. This one we could say, yes, it's roughly quadratic. Okay, let me see what I said here. There's the graph. Yeah, okay, I said the same thing. So that's the big thing with quadratics. You want to look for that U shape, or if it looks like this is also quadratic. This is like the motion of a projectile launched in the air. You shoot an arrow up in the air and then it comes back down. Like my friend Seth and I shooting arrows in my backyard. Weren't being very smart, but it made this kind of quadratic motion. That any type of shape where it makes a U or an upside down U or like a lowercase n, that's a quadratic shape. Like this next example, when you sketch out the graph, that looks pretty quadratic.